Okay, guys, we gonna okay, video capture is losing. Why? What's the problem? Kind of weird. Uh, Camera. Okay, so today I gonna explain again about the thing that we learn. I mean, we are still discussing for ACS exam, the chapter 5, guys. So uh hopefully I can finish for the chapter 5 only for this session, hopefully. Okay, so let's get started. So let's do the best for this part. Okay, all right, so let's I need to read. Okay, so now we start for ACS exam for chapter 5. Okay, for chapter 5. Okay, uh let's go through for the first question. As usual, I will show you the concept, okay, and then we're gonna choose which option that might be the correct answer, and then at the end I will give you like summary of the concept, and then I want to double check with the key answer. Okay, so let's get started from this part. So now we are discussing solution and aqueous reaction part 1. There is another part which is for part 2, but we will discuss later on, not now. Okay, so we already finished for atomic structure, electronic structure, and then stoichiometry for the basic one. I mean, a mole, and then others, and then the last part is about stoichiometry itself. I mean, in the reaction. Okay, so now we are moving on. Another chapter, chapter 5, solution and aqueous reaction part 1. Okay, now let's take a look at for the first question. This question is still study question, not the practice question. So we're gonna learn like step by step and then solve the problem like slowly, not kind of like the practice question. Okay, but overall, both are the same. Okay, both are both looks same. Okay, from the was that for the study chapter and the practice session. All right, let's start by understanding the question first. Which compound is a weak electrolyte when dissolved in water? Okay, let's start by understanding electrolyte first. Okay, electrolyte first. Okay, what's the meaning of electrolyte? Okay, electrolyte. Okay, electrolyte is, okay, when a compound dissolve in water and conduct electricity. Okay, it's called electrolyte. Okay, when a compound, okay, a compound dissolve in water and conduct electricity, conduct electricity. All right. So now we know that electrolyte has like the electrolyte itself has kind of like different types. So kind of such as the strong electrolyte and then weak electrolyte. Okay. First of all, strong electrolyte. We discuss about strong first. Strong electrolyte is okay is electrolyte which completely dissociate completely dissociate into ions. Okay, while weak electrolyte is just partially dissociate. Okay, now let's discuss or let's analyze the choice. For the first choice, this one is nitric acid. Okay, nitric acid, a strong acid. Okay, therefore strong electrolyte. So if we dissolve in water, we will get added up. We will get like H plus and then NO3 minus. Okay, absolutely completely dissociation into ions. How about the potassium hydroxide? Potassium hydroxide is strong base. HNO3 is acid or strong acid. Okay. How about the NH3? Okay, when we dissolve this one into the water, okay, so it will be K plus OH minus. Okay, and then how about the NH3? Okay, ammonia is a weaker base. Okay, is a weak base. And here the key. Here is the key. It only partially ionized in water. That's classic weak electrolyte behavior. Okay, that's classic weak electrolyte behavior. So most of cases, okay, weak base would be weak electrolyte. Electrolyte. Okay, how about the NaNO3? This is the ionic salt. Okay, and then fully dissociate. Okay, making a strong electrolyte. So remember, just quick information. If it's a weak acid or a weak base, acid and base, okay, as long as both are weak, okay, weak acid and weak base like NH3 and COOH, okay, it's weak electrolyte. Strong acid, strong bases, okay, strong acid, strong base, and soluble salt are strong electrolyte. Okay, strong electrolyte is acid, like strong acid. Okay, strong acid, strong basic. Okay, strong basic. Okay, and then the last one is strong soluble salt. Okay, so just remember the principle of weak and then weak acid and weak base. Okay, weak acid and weak base. All right, now move on to another part. Okay, what mass of magnesium nitrate MgNO32 are required to produce 250 milliliter of 0.0750 mol 750 mol solution. Okay, molar solution. Okay, so we are moving into solution chemistry. We are asked to calculate how much of magnesium nitrate is needed to make 250 milliliter of 0.07 molar solution. Okay, here is the plan. Here is the plan. Here is the plan. Okay, first of all, we need to know, use the molarity formula. Okay, we need to use the molarity formula. M times V. Okay, remember M times V. Or maybe you more familiar with the M N per V, which is N is mole. Okay, so after that we get mole, right? So mole is 0.0750 and then times 250 milliliter, and then this is still mole. Okay, mole over here is, remember guys, this one is still milliliter. We need to convert it into liter, so it should be 0.250 milliliter. So the answer of this, I mean the answer of this calculation is 0.01875. Okay, so we are asked like what mass of magnesium nitrate are required, like needed to produce 250 milliliter of 0.06750 m solution. Okay, so we already get the mole of the solution itself. Okay, we already got the mole of solution. Now we need to number 2, we need to find the molar mass. Find the molar mass. How to get that one? We can take a look at from the periodic table. Mg and O32, it will be 148.33 gram per mole. Okay, now what we're gonna do is convert mole to gram. Mole to grams. Okay, how to do that? Moles to grams, just simply multiply this number, mole 0.01875 times 148 300 gram per mole. Okay, because this one is small, so it will give us like gram over here. So the answer it should be 2.79 gram. Okay, the answer should be D. It's very easy. So like how much mass of magnesium nitrate is needed to make this one? So using this mass, okay, 2.73 gram magnesium nitrate, we can produce 250 milliliter of 0.0750 molar solution. Okay, molar solution. Okay, just remember molarity times volume, it will be moles. Okay, so that's the key. All right, now moving to another part. Okay, moving to another part for the number 3. What mass in gram sodium Na plus are there in 25 milliliter of 0.75 Na2SO3? So to solve this problem, guys, we need to use kind of like, as you can see, Na2SO3, it will be and 2Na plus, right? And then SO3 to minus. All right, so the issue here, what mass of Na plus are there in 25 blah 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 of this one? So now we need to take a look at this one. We need to find out the mole over here. Okay, we already discussed in the stoichiometry in the previous part, but now we apply over here again. Okay, so M and V. Okay, what's the volume here is 25. It will be give us 25. Let me calculate again. 0 0.0 25, yeah, 0 0.025, and then mol over here, and then m is 0.75 times 0.75. So we ended up getting, for the mol is 0.01875. Okay, we put in over here 0.01875, and then remember the coefficient here is 2, so it will be getting 0.0375. Okay, this is small, this is small. Okay, now we already know the mol Na. Okay, we already know mol of Na plus, which is this one. So how to convert it into gram is pretty easy, just using the mass. Okay, this is mol, right? So mol is gram per mr, or molar mass. Okay, mol is 0.0375 times what? Times 22.99, and then it will be gram. And then now times to 2.99. It will be gram 0.86. So the answer will be B. Let's double check our answer. Number 3 is B. Okay, it's pretty easy. Okay, as long as, like I mentioned, you know the formula of molarity, and then the formula to find the moles of Na plus. Okay, and then convert Na to gram using the mass equal mol times molar mass. Okay, always look at subscript in the formula to figure out how many ions are produced in the per unit. So in this case, this one produced to Na plus. Okay, and then now we are talking about dilution, where you add water to solution. Okay, as water is being added to concentrate natrium oxide. Okay, when NaOH solution, what's happening? Okay, what's happening? Remember, when you add water, okay, add water, what's happening? You will increase the volume. You will increase the volume. And then remember, mol, the amount of solute in your sample will be remain. Okay, will be stays the same. Okay, will be mol and mol is still same. Okay, and but since the solute is spread it out in more water, and then the molarity is decreasing. Okay, now is decreasing. Remember, volume increase, molarity decrease, and then moles stays the same. Okay, remember this concept. When you add water, okay, when you add water, the volume it will be increasing, right? The volume will increase. And then because since the solute itself like spread it out, okay, is spread out in more water, so the molarity decreases. Okay, if you take a look at the formula of molarity, okay, it has relation with volume. Okay, with volume, and then it's kind of like reverse. Okay, opposite, not linear. So okay, unlinear. So if volume increase, m will be decreasing. How about the moles? Moles if itself not changing, because gram per mr, no changing. Okay, no change. Okay, so let's break down the option from here. The moles of solute are decreasing. Nope, not the moles. Okay, the moles of solute are decreasing. Nope, not moles. Okay, not moles. The volume of solution is increasing, yes, and the molarity is decreasing. Yes, that's true. The volume of solution is increasing, yes, molarity is increasing, no. Yeah, okay, not true during dilution. Okay, so dilution, more water, same solute, molarity goes down. Okay, remember that one. Okay, that's good. And then we move on to another part again. Okay, as you can see, guys, you have a picture over here. Okay, you have a picture, and then there is a question again about what? Okay, the figure shows a particular representation of the resultant solution and solid product after aqueous calcium chloride and aqueous silver nitrate react. Okay, which species is or percent in excess? Okay, which one that percent is in excess? Okay, let's break it down like this. Okay, identify the reaction type first. Okay, so this is the equation, this is the equation, right? Given reaction kind of like this, and then now identify the reaction type. Okay, this is a precipitation reaction. Why? Look at the silver chloride. Okay, look at the silver chloride. So as you can see, the symbol over here is the subscript over here is solid, which means it indicates that the type of reaction here is was that the precipitation reaction. Okay, precipitation reaction. And then what else? Okay, so number 2. Okay, we know this one is it will produce. Okay, this is the precipitation. So it will be form solid. Okay, it will be form solid. Okay, number 2. Okay, number 2 is understand the ionic equation. Ionic equation. Okay, now let's take a look at more detail. CaCl2, okay, it will give us Ca2 plus 2Cl minus, right? How about the 2NgNO3? So this one, you don't need to put in 2 over here, just Ag plus and then NO3 minus, okay? When mixing together, when put our mix, let's see that Cl will be mixed with the Ag. It will form solid to being AgCl. Okay, in the solid formation. So it precipitate. Okay, precipitate. Okay. Which species is or present in excess? Okay, which one that present in excess? And then analyze the diagram. Right now, analyze the diagram. So we will getting for Ca1, 2, 3 anymore. Is there any more? Nope. So Ca2 plus will be 3. How about the Cl minus? 1, 2, 3, 4, 5. 5. How about the NO3 minus? NO3 minus 1, 2, 3, 4, 4, right? It looks like 4. And then let me thinking first. Cl minus. Okay, Cl minus. And then wait. This one is HCl. Okay, HCl. Okay, and then this one is, oh, okay, I know. The figure shows a particular precipitation of the resultant solution and solid product after acquisition. Okay, so this is the precipitation, guys. This is the precipitation itself. Okay, and then another one is, this one is representing of the solvent itself. So let's revise our approach here. So Ca2 plus will be 3, exactly same. How about the Cl minus? It will be just 2, because just this and then this, and then NO3, it will be 4. Okay, it will be 4. This tells us that Ag plus, okay, is not excess. It's not excess. Okay, it's not excess. It's all used to. Yeah, okay, use up to form HCl. Okay, so completely react. Okay, completely react. So it's all use up to. Okay, use up to form HCl. Ag is not excess. Okay, how about the Cl minus? Cl minus, as you can see, guys, they already form the solid again over here. I mean, they form solid as well. However, okay, but however, as you can see in the solution, they are still remains over here. Okay, so extra remains. So as you can see, because this one is still remains, so it will be excess. Okay, excess. How about the Ca2 plus and then NO3 minus? Both are spectators and remain in solution. Both are spectators. This one, right? There is no change over here. Okay. So the thing that only change is just Cl minus. Okay. Um, let's take a look at the answer. Now, the answer will be only Cl. Okay, Cl minus. It will be only Cl. So what's the previous answer? The previous answer is C. And then now is, let me take a look at this question first. I just want to make sure I don't want to get any kind of like mistake for that one. E. Hmm. So it looks weird. So the answer is B. However, we need to take a look at one by one. Again. Let's think more. Mm, 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 mm. So E plus Cl minus. So the answer is B, but I don't know how to get this one. Okay, how to get this one. So let's take a look at for the answer first. Okay, so ah okay, we can start this question by evaluating the balance equation for reactant and product. First, looking at the product, you see the HCl is the solid that is formed, and CaNO3 is in solution or spectator ions. Okay. Therefore, on first inspection, looking for excess reactant, you might think that chloride is the only ion in excess. Okay. Okay. All right. Yeah, like I mentioned, because over here the was that the this one is already precipitate, right? So the excess uh species, it will be only Cl minus. Okay. However, the aqueous product of calcium nitrate yields to nitrate. Oh, let me see. Yields to nitrate. Yields to nitrate ion. Yields to nitrate ion exactly for each calcium nitrate. Okay, so CaNO3 2, it will be Ca plus and then plus NO. Wait, no, not this one is Ca2 plus and then NO. This is minus, this is 2. Okay, again, it will produce the yield to nitrate of ion. Okay, this one for each calcium nitrate. Okay, exactly. This means that to calcium ion and 4 nitrate, okay, are the product, leaving 1 calcium ion and 2 chloride. Wait, this means that to calcium and 4 nitrate to calcium over here, and then 4 nitrate, this one, okay, leaving 1 calcium ion, okay, so it will be Ca2 plus 2NO3 minus, right? Leaving 1 calcium and then 2 chloride. What? It doesn't make sense. Oh, I got you guys. So it will be product. Oh, so leaving this one and this one. Okay, I got you. Okay. We don't need to use kind of like what? Much more complicated. No. Okay. Just take a look at the picture. Okay, take a look at the figures over here. The figure here, as you can see, the product, this one, okay, the product of this one, okay, one of product is this one, and then as you can see, there is another Cl minus over here. That this one certainly 100% is excess ion, excess species. However, when we are looking at this product, okay, we will get, if we want to break it down again, it will be Ca2 plus and then NO. Need it one Ca need to 1 Ca needs 2 NO3. So this one and this one. this one and this one. So this one the excess one, and then this one and excess one. So it will be Ca2 plus and then Cl minus. All right, that's good. That's good. There is no issue at all. All right, and then let's move on to another part. Which reaction will result in precipitate? Okay, precipitate. Let's test each one by one. Okay, so how to know this one? Precipitate, it means insoluble. Okay, insoluble, solid. Okay, use solubility rules. How to get the solubility rule? Most sulfide, okay, S2 minus are insoluble, are insoluble. Okay, so as you can see, guys, let us let's test each one by one. Okay, FeCl2 and A2S. Okay, it will be give us what's that? Let me think first. It will give us like FeS, right? FeS. All right, that's true. That's true. And then plus NaCl. Okay, so just put it over here 2, then ACl, and then FeS. Okay, and then this one, it will be solid. Okay, so the answer will be A. Okay, like I mentioned, okay, most sulfates are insoluble when they are like when they mix with the what's that, with the metal like Fa2 plus. How about this one? KPR, no, KPR is soluble, and then CaCl, it's also soluble. Okay, so all product are aqueous or liquid water. Okay, over here, no, for the C1 is non-soluble combination, no precipitate. So all ions are soluble. Remember, all ion in this case is soluble. All ions, which is K plus, Cl minus, Ca2 plus, and then Pr minus, those are soluble. Okay, how about this one? This one is H2O. It will give us H2O, and then Na2SO4, Na2SO4. Both are in, all product are aqueous or liquid. Okay, how about this one? How about the D one? All product ZnL2 and then HNO3 are soluble acid or salt. Okay, this one is will be Zn okay, I right, and then another one, it will be HNO3 2. Okay, so this one, it's a soluble. Okay, this one is salt, right? And then another one is acid, so it will be soluble. So the correct answer will be A. Remember, most sulfate are soluble in, like insoluble. Most sulfate are insoluble when mixed with the metals. Okay, remember this concept. All right, let's take a look at for the question again. Okay, so remember the key here. Criteria for precipitation occur when, okay, occur when both are solution. Okay, put R solution. Okay, precipitation occur, put R solution. And then number 2, at least one product must be insoluble. Okay, product must be insoluble. Okay, if you take a look at what's that, the subscript, it will be if those are insoluble, it will be S, and then if the reactant are all soluble, it will be AQ. Okay, so yeah, the correct answer will be A, correct. Okay, FES. Okay, FES. Okay, so just remember this concept. Okay, most sulfate are insoluble. Okay, are insoluble. But the thing here that probably sometimes we getting confused for this part, ZNI, it will be insoluble or not. Yeah, this one is salt, and remember salt can kind of like soluble in water. Okay, kind of like soluble in water, kind of like this. Okay, so yeah, let's take a look at four others. Again, this is 2, right? ZNL2, ZNI2. Okay, so now the next question. What is the net ionic equation for the reaction between this one and this one? Okay, net ionic. Okay, remember the net ionic principle. I will give you guys the concept. So hopefully using the concept that I taught you, it will be helpful if we have kind of like different type of question. Okay, so let's take a look at for this part first. Okay, so what the thing that we need to do, okay, let's decode the reaction first. Okay, write complete ionic equation first. Okay, and A2S plus PP and O3 2, but remember, yeah, you need to write down for the subscript. Okay, and then it will be what's that, with it will be PPS, right? PPS, and then 2Na, no, NaNO3. Okay, yeah, that's true. 2NaNO3. All right, so now let's break it down ionic form. Okay, and A2S, it will be Na, 2Na plus S2 minus. Okay, how about this one? This one, it will be PP 2 plus, okay, and then 2NO3 minus. How about the PPS? PPS, we don't need to do that. Why? Because it like solid, so we don't need to break it down. Okay, how about the NaNO3? Okay, remember S. Okay, remember S. Most of the sulfate kind of like insoluble. Okay, remember. To how to get this one? Na plus plus NO3 minus. Okay, still in aqueous. So net ionic means where we cancel out the spectator ions, those that don't participate in the chemical chain. So what actually react over here is just S minus and PP2 plus. Okay, which one that which one that actually react over here? So as you can see, PP and then S, and then however over here it just still aqueous, no change. Okay, those that don't participate in the chemical change. Okay, remember net ionic equation. Okay, net ionic means we cancel out the spectator ions. Cancel out the spectator ions, those that don't participate in chemical change. So which one it is? It should be this one. Okay, it should be this one. Okay, just testing one by one. I mean, not testing. I mean, we need to break it down one by one. Okay. Choice P is the molecular equation. Okay, molecular equation. molecular equation. For C is kind of like cancel only one spectator, ion, Na plus, but not nitrate ion. Okay, still nitrate, but not nitrate ion, so it just cancel out for Na plus, but still NO3 nitrate still over there. So we need to cancel out what, like those that we need to cancel out other. Okay, cancel all ion that appear the same as both reactant and product. Okay, something like that. Okay, so I just want to give you guys the good answer. I mean the good answer, the way that might be much more understandable. So let's take a look at this one first. Okay, so we need to break it down for the equation, this one. Okay, and then we're getting ended up 2Na plus, right? And then plus S2 minus. Okay, and then plus again PP. Okay, 2 plus, and then plus 2NO3 minus, and then 2Na plus. Okay, and then plus 2NO3 minus, and then plus PPS. Why PPS? Because PPS is still what, in the solid form. Okay, to be in the solid form. This one is insoluble. Okay, so based on this information, we can cancel out one by one. Okay, we need to cancel out one by one. How to do that? Cancel all ion that appear the same as both reactant and product. We need to cancel out both sides. Okay, either in the reactant or product. Na plus with Na plus. S2 minus. Nope, there is no S2 minus. PP2 plus. Nope. NO3 minus. Yes, we need to cancel out this part. So which one that net ionic? S2 minus plus PP2 plus being PPS. So the answer should be A. Alright, so it's done for this part, and then we can go through another part. Okay, which the best illustrate how weak acid HF exists in aqueous solution. Water molecules not shown here. Okay, let's review what happened with weak acid. Okay, weak acid will be partially ionized. Okay, partially ionized in water. And then that means some okay, stay together as molecules. So we are looking for a mixture of HF not fully ionized, okay, not fully ionized, which means not all spirited, not just HF molecule, not zero ionization. Okay, which one it is? So the first picture, I mean the first figure for the A option, all of them kind of like what? All of them intake HF ion. Okay, HF, and then it will be no ionization. It means wrong. How about the option B? As you can see, you see the mostly HF, okay, over here, and then you will see F and H, which mean partially ionization, and then it perfect for weak acid. Okay, and then again, how about this one? H plus and then F minus. Too many free ion. Okay. Oh, how about the C? The C one. Oh. Let me think first. Again, I think there is something. Okay. we need to consider was that the charge. Okay, we need to consider the charge. Okay, it is kind of like this one for the B option is kind of like correct. However, there is no charge over here. There is no charge, which means incorrect as well. And then the option C, as you can see, there is a charge for H and then F. Okay, for H as well as F minus. So regarding this option, regarding the definition of weak acid, we want to know partially ionized. Okay, which one that partially ionized in water? So it will be C. And then for D option is too many ionized, which means it's kind of like definition of strong acid. Okay, strong acid, not like a weak acid. Okay, therefore the choice C is correct. Therefore choice C is correct. Okay, and then let's move on to another part again. As you can see, there is a oxidation number. Now we move on to another kind of like another concept about the oxidation number. Let's take a look at what is the oxidation of MO in MOO4. Okay, let's take a look at for this one. MOO42 minus. As you can see, guys, O4 it should be contains minus 2. Okay, minus 2. And then, as you can see again, O over here, there are 4 O atoms. Okay, which mean it will, like, you just time minus 2 and the minus 2, you just multiply 4 with 2 minus 2, so it will be minus 8. Okay, and then the overall charge, okay, the overall charge is minus 2. Okay, is minus 2, the overall charge. Okay, remember, oxygen is always minus 2. There are 4 atoms for each minus 2, so the total is minus 8. The overall charge of the ion is minus 2. Okay, let's calculate for molybdenum over here is MO. Okay, so like we don't, yeah, you can use the equation or other stuff like kind of like X. So X minus 2 plus 8. Okay, so it will be 6. So the answer will be 6. Okay, okay. And then again, which combination is correct for the reaction represented by this equation? Which combination is correct? Okay, which one that oxidize, which one that reduce? Okay, now we know we will get another concept again. Remember, we are identifying who get oxidized and who get reduced. Things kind of like a thread. Electron are being passed around. Okay, oil rig help us. Okay, so there is a oil rig. Oxidation. Okay, oil rig. Oil rig. Oxidation is loss. Reduction is gain. Okay, rig, oil rig. Okay, oxidation is loss, reduction is gain. What's the meaning of this one? Loss of what? Electron. Oxidation, loss of electron. Reduction, gain electron. So let's take a look at one by one. Okay, assign, the first step is assign oxidation number. Determine the oxidation number. Okay, Cu in solid form, Zn 2 plus in aqueous form, Zn again solid, Cu 2 plus aqueous form. Okay, now let's take a look at Co being CO2 plus. Okay, from CO, from neutral, went from 0 to plus 2, which is lost what? Electron. Lost electron. Okay, because this one is lost electron, so we gain, this one is oxidation. And then the other part, the other side, on the other hand, we can see CO2 plus went from 2 to 0, which is what? Which is gain electron. So this one is reduction. Reduce. So oxidize is Co, and then reduce is what? Zn2 plus. Okay, so now matching up with this option. CO is oxidized, Zn2 plus is reduced. So the answer will be A. Okay, quick tip. When in doubt, okay, when in doubt, track the electron. If element goes up, okay, if element goes up in oxidation number, it's oxidized. Down, reduce. Okay, if element goes up in oxidation number, okay, so as you can see, this one is 0, right? And then this one is 2. Goes up is oxidation, and then go down, this is from plus 2 and then becoming 0. Okay, it will go down is reduce. Or you can remember this concept, oil rig. Oil rig, oxidation is lost electron. Okay, reduce is gaining electron. Okay, that's great. Okay, so the answer will be what? Will be A. A will be A, yeah. This one is kind of reverse, okay? This one is reverse the okay, the assignment, and then Zn and D are product rather than reactant. So just focus on in the reactant, not the product, okay? All right, so now moving on to another part again. This is the last study question, guys. For the next part is the real exam question. Okay, so I will pause for a while, and then I will be back to finish for the for the real exam. Okay, so now for this reaction, what are the oxidizing and reducing agent? Which one that oxidizing and reducing agent? Still same concept, to just focus on the reactant, guys. Okay, so we can, if you kind of like getting confused, we can eliminate which one that appear for product. Is there any HCl? Okay, this one is not correct. This one is incorrect again. Okay, so just take a look at the option A or B. Okay, just take a look at option A or B. Okay, 2AuCl3 minus plus 3H2, and then 2Au plus 6HCl. Okay, we need to determine the number, the number of each one. Okay, in redox reaction, one substance lost electron and then the other gains electron. Okay, remember, oil rig. Okay, oxidation is what? Losing lost electron, right? And then reduction is gain electron. Okay, so the oxidation, the question is agent, guys. Agent, oxidizing agent is the one that get reduced. Okay, the one get reduced. Okay, the previous question is not agent, but which combination for reaction represented by this question. Okay, remember this one is agent, which mean like kind of like opposite. Okay, kind of like backwards, right? But it's because they are named for what they do to others. Okay, so kind of like opposite or kind of like backwards. Okay, so remember, in redox reaction, one substance lost and then the other gains. But remember this key that the oxidation agent, remember agent is, okay, get reduced, and then reducing agent is which one that get oxidized. Okay, now take a look at the answer, the option. Cl minus AU, so 3 plus, and then this one is minus 1. Okay, minus 1. This one is should be 0, and then this one is AU, right? AU. Okay, AU is over here is 0, and then HCl is minus 1, and then this is plus 1. So which one that okay, as you can see guys, AU from 3 plus when 3 to 0, which is with this definition, okay, this will be lost electron, right? Plus 3, oh wait, lost electron, 0 to, okay, from 0 to 2. Okay, this one it will be reduction guys, yeah, this one is will be reduction, so gaining electron. So from plus 3 to 0, so this one is gaining electron, so it will be reduction. How about the Cl minus? Cl minus still remaining over here, still remaining. Okay, still remaining. However, how about the O2? O2 like opposite. O2, okay, from 0 to plus 1, from 0 to plus 1, which mean it lost 1 electron. So this one is oxidation. Now we good. Okay, so now we need to identify the agent. Okay, H2 is oxidized. Okay, so H2 is oxidized, so it's the reducing agent. This is reducing agent. And then AuCl3 is reduction, so it will be what? It will be oxidizing agent, kind of like just the name. Okay, just kind of like the name. So oxidation agent is AuCl3, and then H2 is reducing agent. Remember the name of agent. Okay, the concept is this one. However, oxidation agent is cause oxidation. Okay, cause oxidation. Okay, remember oxidizing agent, it causing oxidation. Okay, causing oxidation, causing this one being oxidized. Okay, so kind of like this way to answer this question. All right, so I need to take a rest for a while, and then we'll be back and then try to finish for the remaining question. Now we are good, and then we will solve the real example of ACS exam. Yeah, you can take a look at the answer. I mean, you can try first, and then we can double check after that. Okay. Ngajar. Kenapa? Iya, bentar lagi ya selesai. Hmm? Iya. Sakit. Kenapa? Kenapa? Oh, kamu ini sana. Dicuci matanya. Mami cuci matanya sakit. Okay, guys, we continue our discussion again. So it looks like I'm not activating my sound, so it's kind of like mute, right? I'm so sorry for this inconvenience, guys. Okay. All right. So now I understand why the C1 is not is incorrect, because this one is solid. So it should be not solid, right? It should be all of them in the aqueous solution. Okay, in the aqueous solution. Okay. All right. So why this one is incorrect? Okay, because this one is in solid. It should be in aqueous. Okay. Okay. The net ionic will in. Okay. So for to know H2O, so we would have like strong acid and then strong base. So after that we can get the fully dissociate. Okay, fully dissociate for each acid and then basic. So rather than using this part, I think this one is incorrect. Because of what? Because this one is in solid. It should be in liquid. Okay. All right. So now again for number 19, what is the balanced net ionic equation from reaction of CuCl2 and the and H2? What is that one? Gas. Okay, gas. What is the balanced net ionic? Okay, CuCl2, it will be Cu 2 plus and then plus 2Cl minus. Okay, and then it will react CuCl2, it will react with the H2 becoming Cu. Okay, becoming Cu, and then as you can see, this one is gas, this one is aqueous, right? So it will be Cu, and then it will be produced. It's kind of like, I think like it's not HCl actually. So this one is redox reaction. Is I'm pretty sure this one is redox reaction, because not the redox reaction kind of like we have different kind of the phase over here, right? So CO2 plus, okay, from this one is what is what this one, from this one, wait, CO2 plus, wait, let me think first. This is plus 2, this is minus 2, okay? This is plus 2, and then this one is minus 2. And then for H2, I just want to see. Okay? And then there is H2, it will be 2H plus and then 2 electron minus. Okay? So we can put in over here the reaction. So the balance, it will be CO2 plus, right? And then what else? Okay, let me think again. CO2 plus is reduced to Cu. CO2 plus reduced to Cu. And then H2 is oxidized to H plus. Okay. So now we need to reverse this part. Which one? Okay, we need to understand which one being reduction, which one being oxidation. Okay. So CuCl2, Cu will be, so plus 2 will be 0. So it gains like a oil rate. Okay, reduction, which mean is gain electron. So Cu will be reduced. Okay, Cu will be reduced to plus, being Cu, right? And then H2 will be being H2 will be being what? 2H plus 2 electron. Okay, it will be something like this. Okay, and then from here you can see as well CuCl2 being what? Cu2 plus 2Cl minus. Okay, if we break it down one by one, it will be something like this. Okay, so remember the concept of it is, this one is redox reaction, so we need to determine one by one first. So as you can see, the reaction will be I mean, after that, for full balance, it will be CO2 plus, right? And then plus H2. So we can like eliminate this part. Okay, eliminate this part. Okay, and then we will get the Cu, and then we'll get 2H plus, and then 2 electron. Okay, and then yeah, it's good, CO2 plus H2 Cu, and then 2H plus, so it will be A for the answer. Okay, so we don't need to put in like this one, right? So like I mentioned, we need to understand first. Okay, we need to understand first like which one being what, oxidation, which one being reduction. Okay, Cu from here, from this one, is already plus 2, and then we want to make it 0. Okay, CuCl2, we want to make it 0. So Cu2 plus, okay, being Cu, and then H2 being 2H plus. How about the Cl? We don't care. We don't care for the Cl. Okay, we don't care for the Cl because we need to determine like which one that reduction, which one that oxidation. All right. Okay. Okay, that's good. That's good for number 19. Okay. And then number 20, what is the weak acid in water? Weak acid in water. Okay. We need to understand the concept. What is the weak acid itself? Okay. What is the weak acid itself? Okay. Which one that weak? Pr? No. Cl? No. Hi? No. The answer should be HF. Why? Strong acid is fully ionized in water. And remember, HCl, Pr, and Hi are strong acid. Hydrofluoric acid. Hydrofluoric acid is different. Even though it's halogen acid, right? HF is weak because strong hydrogen bonding. It only partially dissociates. So it will be C for the answer. And then what's the particle will be present in NH3? Okay, will be present in NH3 aqueous. Water molecule, exactly. And then what? What else? NH3. Okay, what else? Okay, and then if we put it in water molecule, it will be what? NH4 plus and then OH minus, right? That means in solution, you mostly have what? Water molecules, okay? And then some NH4, okay? And then some OH minus, and of course, water molecule itself. Okay, so it will be, the answer will be of what? Water molecules, NH3 molecules, and small number of NH4 ions and OH minus. Okay, the answer will be D. What is the oxidation number of chlorine NaClO2? This one is easy. The 2 will be -4 and H will be 1, and then this one will be 3. So the answer will be C. What is the oxidation number of chromium in Na2Cr2O7? Na2Cr2O7. This one is -14. This one is +2. And then Cr2 will be what? Oh, boop, 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 boop. Okay, it will be Na. Okay, this one is mine. Okay, so it will be 12, right? We need to have 12. However, we need to, because it has 2 Cr, it will be 6. Okay, it will be 6. So the answer will be 6. So B, not 12. Remember, not 12. Okay, not 12, because Cr contain, there are 2 Cr. Okay, there are 2 Cr. So number 23 will be B. And then in which compound does vanadium has the lowest oxidation state? Okay, this one is -2, this one is +2. Okay, this one is -4, this one is +4. This one is -6, and then this one is +3. This one is -10, and then another one, this one is +5. So the lowest oxidation state, the lowest one. Okay, the lowest one will be +2, right? The lowest one will be +2, so 24 will be D. Okay, the lowest one. Okay, the lowest one. Okay. And then again, what is the example of oxidation like redox reaction? Redox reaction. We need to determine which one that being oxidation or being which one that reduce, which one that oxidize. All right. So redox is transfer electron, right? Someone is oxidized or lose electron, or someone is reduced gain electron. Oil rig. Okay, oxidation will lose electron, reduction will be gain electron. Okay, let's check one by one. Okay, for this part, it's kind of like aqueous and aqueous. So it looks like uh, not redox reaction, right? Not redox reaction, because acid base reaction is this one, okay? Acid base reaction. And then how about the B? Okay, how about the B? This is a solid, and then this is a gas. Solid and gas. Kind of no. There is no reaction over here. It's just one solid, right? It should be not. It should be not. We have to have at least two. Okay? How about the C1? How about the C1? PPNO32 and A2SO4. Okay, let's take a look at this bar. Aqueous. Aqueous. Okay, let me check it first. This one is -2, right? This one also -2. This one is what this one is +1. This one also +1. This one -1. This one +2. This one +2. This is -2. So no, there is no redox reaction. So it will be D. PP 0 +2, right? Okay. And then over here is -2. It is +2, and then it will be +2 again. And then how about this one? -2 +2 -2 and then +1. Yeah, there is a redox reaction over here. So PP oxidation state, right? 0 is oxidized. It will losing electron. Okay, losing electron. And then PPO2 also from 4. Okay, from 4. Sorry, not 2. From 4 being +2. Okay, so over here with this one. Oh, sorry. This one again. Ya. Bentar lagi selesai. Okay. Now we move on to the last two slide. Okay, we almost done for number 1 to number 30. Oh, that's great. In which reaction is carbon reduced? Okay, this is 0, right? This is +4. Which one that reduced, guys? This is -1, -2. This one is +2. No, this one is increased, not this one. Okay, not this one. So the previous one, the number 25, it should be D. Yeah. And then again, CO2 -4 +4, right? H4, it should be nothing like this way. Okay, CH4 is kind of like -4 and then +4, so it's kind of like same, so it should be not. And then this one, my +4 and then -6 +2 is 4. Nope. Right? How about the last one? -2 +1 -4 +4. Oh, let me see for the option D. H2 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 is -1, right? Oh yes, this one is +1. Okay, and then this one, this is -2, right? Oh, I'm so sorry, guys. I'm so sorry, I got wrong. H should be plus, right? H should be plus. +1 and then -1 plus 1 -2. This one is reduced. Okay, D. This one is plus 1, and then this one is plus 4. How about this one is still same, minus 2, and then plus 4. So still same. And then this one is not reduced but increased. Okay, the first part is oxidized, not reduced, guys. This one is oxidized, right? Okay, now number 27. Which example of oxidation reduction reaction? Again, this one not, this one not. Why? I can understand directly. It's pretty easy because 27 for let me check it again, guys. Yes, this, how about this one? This is solid aqueous. Okay, let's see. It's probably, I'm pretty sure the example, why the, okay, let me see first. Op. Let me think. This one is not, okay? This one is not. CA stays plus 2, right? Minus 6 and then plus 2. Okay, that's good. And then how about C? And A plus 1. And then this is also plus 1. Which one that changed? Minus 1, minus 1, minus 6, minus 4, minus 2. No oxidation number change right over here. This is plus 1. Then this is also plus 1. Yes, there is no change. Okay, and then how about the D option? Okay, how about this one? This one is 0, and then it will goes minus 4, and then this one is 2, minus 2. Okay, and then this one is plus 1. Okay, P redox, right? P redox. Yeah, P is redox reaction. Oxidation and oxidation. Reduction and oxidation. Okay, good. What are the oxidation agent? And this one is agent, right? Agent and agent. So which one that just like opposite? Okay, opposite. Okay, this one should be minus 2, minus 1, right? And then if because it's 2, this is 2 plus. So Cu here is 0. So from plus 2 to 0 will be oil ring. Loose electron, right? Loose electron, yes. So it should be oxidation. Cu should be oxidation. And then vanadium, this is minus 1 again. And then vanadium is plus 2 as well. And then this is minus 3. This one is plus 3. So this one is reduction. Wait. Cu plus 2 to 0. Oh, gaining electron. Sorry, gaining electron reduction. This one would be oxidation. So this one will be vanadium will be agent, oxidation agent, reduction agent, and then Cu is no. It should be yeah, reduction agent, and then Cu will be oxidation agent. V will be oxidation reduction agent. This one. And then Cu will be oxidation agent. Yeah, should be P 28. Okay, 28 P. Okay, guys, we wanna do for the last part. The last part of this topic. Okay, we almost done for the last part. What is the oxidizing agent in this reaction? Again, oxidation will causing the reduction. Oxidation agent will causing reduction. Pt is 2 plus, and then it will be 0. So which one that this one Pt is kind of like what? Reduction, right? Reduction. Okay. So oxidation agent, Pt is oxidation agent, I'm pretty sure. How about the other one? I'm pretty sure this one will be what? Will be oxidizing agent. Okay. So wait, plus 2, and then from plus 2, oh, gaining electron is reduction. Yeah, gaining electron reduction, so oxidation agent. Yeah, the answer should be A. Okay, so remember, this is a reduction, right? However, we can say this one is oxidizing agent. Okay, oxidation agent. Okay, that's good. Which statement about this reduction is correct? O2 as the oxidant in this reaction. O2. H2O2 act oxidation agent, reducing agent. Only oxidation has taken place. Okay, let's see. This is plus 1, right? And then this one is minus 2 plus 1. Okay, there is no change. How about this one? This one is 0. How about this one? This is minus 4 and then plus. I mean, okay, should be plus 2, right? Okay. And then okay, it should be minus 2 and minus 2, right? Okay. So oxidation over here, this is yeah, oxidant in this reaction exactly. No, not the oxidant. Okay, H2O2 act oxidation agent. No, it should be reducing agent. Yeah, it should be reducing agent P. Yeah, because this one is oxidation, right? And then as I mentioned that which one that causing oxidation, it will be reducing agent. So reducing agent. Okay, so in we can say another thing like oxidation or reducing agent. Okay, H2O2. Okay, guys, we done. I'm so tired because I'm so excited because we already live like almost 3 hours to learn all of this thing done. Okay,